What is antimatter? Put simply, it's normal matter with an opposite charge. For example, there is a proton and an antiproton. A proton has a positive charge. An antiproton is the same as a proton with a negative charge. It has the same mass, the same spin, and the same isospin. The only difference is charge. Well, why is that important? In 1928, British physicist Paul Dirac wrote down an equation that combined quantum theory and special relativity to describe the behavior of an electron moving at relativistic speed. The equation, which won Dirac the Nobel Prize in 1933, posed a problem. Just as the equation x squared equals 4 can have two possible solutions, x equals 2 or x equals negative 2, so Dirac's equation could have two solutions, one for an electron with positive charge and one for an electron with negative charge. If I took a proton and an antiproton and combined the two, they would annihilate into pure radiation because the total charge is 0. There is no electric charge, so all we would be left with is, and I use this term loosely, pure energy, because E equals mc squared. Just like doomed lovers, antimatter and matter initially attract due to their opposite charges, then come together and destroy each other. Protons and electrons, for example, can't annihilate because they have very different masses. But here's the problem. The laws of physics and quantum mechanics tell us that for every particle there should exist an antiparticle, a particle with equal mass and opposite charge. So where's all the antimatter? In the moments after the Big Bang, all the matter and antimatter should have annihilated, leaving us with nothing but pure radiation. Understanding antimatter could help us solve this mystery. For every 1 billion particles of antimatter, there was 1,000,000,001 particles of matter. This actually accounts for what we see as the cosmic microwave background radiation. Researchers have observed spontaneous transformations between particles and their antiparticles, occurring millions of times per second before they decay. Some unknown force intervening in this process in the early universe could have caused these oscillating particles to decay as matter more often than they decayed as antimatter. Consider a coin spinning on a table. It can land on its heads or its tails, but it cannot be defined as heads or tails until it stops spinning and falls to one side. A coin has a 50-50 chance of landing on its heads or its tails, so if enough coins are spun in exactly the same way, half should land on heads and the other half on tails. In the same way, half of the oscillating particles in the early universe should have decayed as matter and the other half as antimatter. However, if a special kind of marble rolled across the table of spinning coins and caused every coin it hit to land on its heads, it would disrupt the whole system. There would be more heads than tails. In the same way, some unknown mechanism could have interfered with the oscillating particles to cause a slight majority of them to decay as matter. A very interesting fact about antimatter is that it travels back in time. This requires a whole video for itself, but I will expand on it briefly. Put simply, antimatter is normal matter traveling backwards in time. In forward time, a positive charge and a negative charge attract each other, but if we played it backwards, they would seem to repel. Antimatter would then be just that, matter traveling backwards in time. In this diagram, we see that this is a necessary property to create light. So when two electrons are moving forward in time towards each other at some velocity v, they will eventually repel each other because of their same charge. But what happens in the middle? A photon is created. A photon has mass and charge 0, so due to the laws of general relativity, this is necessary. And because of Einstein's equation, the closer to the speed of light something is going, the more the space and time axes become arbitrary. So the diagram can be rotated any number of degrees and still make complete physical sense. If we flip the diagram on its side, two of the electrons seem to be moving back in time, and because of that, they are called positrons, or the anti-electron, and are able to annihilate with the electron to create radiation, which is what we perceive as light. In other words, lots of quantum voodoo that I don't know nearly enough about to continue this video. In any case, antimatter matters.